Here are some overviews as to just encountering the difficult problems, especially the ones that I starred. This is just with solving equations, and we start off with having an equation that has two fractions, which doesn't seem too bad until you realize, wait, I have to get rid of both of them. How do I do that? There's a couple ways that we can do that. Obviously, I can subtract the 1/4, but that doesn't really help me. And then if I remember the past, I said that we should multiply everything. But the problem is when I multiply everything, I have to ask myself, well, how do I do that when I have two fractions? Well, the process is still the same. I want to get rid of this 3, and so one of the ways that I can do that is, well, I multiply everything by 3. So I'm going to put that. I'm going to say times 3 times 3 times 3. But then I want to get rid of the other fraction, the 4, so I can also do is I can also multiply by 4. So times 4 times 4 times 4. Well, let's see what happens, right? If I put a line underneath, what happens to that first one? The 3's, well, luckily it's a fraction, so I'm going to cancel them out. That's something we were learning in class. What happens to the two 4's in the next one? Well, they cancel out because they're a fraction. Can I cancel out anything with the 5, the 3, and the 4? No, it's not a fraction. So I have to leave it like that. And then what I get is this multiplication. 2x times 4, that gives me 8x. I see that I have the 1 up in front, so I'm going to say what's 1 times 3? That's 3. And then lastly, I have this 5 times 3 times 4. Well, 5 times 3, that's 15, and 15 times 4, that's 60. And then we're back to this 2-step. So really, when it talks about this multiply everything, when you have different denominators, the key thing that you want to focus on when you have different denominators is that you still multiply all of them. Multiply all bottom numbers. See, that's the key idea. Multiplying all the bottom numbers to get there. To finish this off, we subtract 3 to both sides just like this. 3's cancel out, so we get 8x equals to 57, dividing both sides by 8 to get rid of the multiplication in front, giving us x equals to 57 over 8. I believe this also gets us to 7 1/8 or 7.125. These are acceptable answers. Let's move on to the next one because this is also related to fractions. 1/2 minus 3 plus 4x equals to 6. I now notice that this one is with one side, but the key idea in this one was combining like terms. I noticed that in this equation that I can combine the 4x with the 1/2 x, but there's a problem. The 1/2 is a fraction, obviously, but just like before, I'm going to combine like terms with multiply everything. So how do I do that? Well, first, I want to get rid of the fraction before anything, so I'm going to multiply everything by that bottom number, 2. So once I do that, I'm going to see what I get. It's a fraction, so the 2's cancel out, giving us 1x. 3 times 2, that's minus 6 because of the negative sign. 4 times 2x is 8x, and it equals to 12. Then I can do combining like terms. So really, this part right here was multiplying everything, while this one right here was combining like terms, and we'll see that. I notice that there's a 1x, there's an 8x, so I'm going to combine them, giving us 9x minus 6 equals to 12. And it's just like the same as before. I have to get rid of the 6, the minus 6. It's a minus, so I do the opposite, which is plus. I add it to both sides, giving us the 6's cancel out, giving us 9x equals to 18. That's 12 plus 6. I want to get rid of the 9, so I divide both sides by 9. The 9's, they cancel out, giving us x equals to 18 divided by 9, which is 2. This is how we figure out the one side. You have to figure out that you have to combine like terms, but if there's anything that stops us, we have to first do that thing, such as multiplying everything. Let's move on to the next one, which, guess what? This time it's both sides, but it has not only both sides, we also need to figure out how to combine like terms. And not even only that, there's also something with fractions. So I had to figure out which ones to do first. I personally don't like fractions, so I'm going to do that one first. I see here I have a 3, so what do we have to do? Again, we have to multiply all the terms by that bottom number, regardless of whatever it is. Let's see what happens. Because we only have one fraction, the 3's, they cancel out, giving us 2x. I see how I have 3 times x, that gives me 3x. I have now 4 times 3, that gives me negative 12. I have next 5 times 3, that's 15, and it has an x. And then lastly, minus 18. Okay, but here's the problem. I now have multiple x's on both sides, on one side and on the other. So what am I supposed to do? Well, I'm going to combine like terms. But here's the thing. I can only combine like terms if they're on the same side. Can I combine the 2x and the 3x with this one? No. The answer is no. And the reason why is because this one is separated by an equal sign. You can't combine them when they're on different sides. So I'm going to combine the 2x plus 3x, giving me 5x. And I'm going to continue on with the rest. I don't combine the 12. I see here I have 15x. And I have minus 18. Now we're getting into how I tackle both sides. I'm going to get rid of one of them, and one of which I can get rid of is probably 5x. I think of the opposite. The opposite of positive 5x is negative 5x. I do it to both sides, just as the following. And because of that, this 5x is gone, leaving me with negative 12 equals 10x minus 18. I have to get rid of now, because of the two-step, the negative 18. This means I do positive 18 to both sides. When I do that, the 18's cancel out, giving me 6 equals to 10x. How do I get rid of that 10? Divide 10 by both sides. The 10's cancel out, giving me x equals to 6 out of 10, which is equivalent to saying 0.6. Let's do the next one. This one is cross multiplication, a tricky one. The goal is to get rid of the fractions. But in order for us to do that, I had to remember a few things. Well, since it's cross multiplication, what I can do is I can create this cross. But wait a minute. I noticed that I have this negative 3 times x plus 2. So I had to write it using this thing called distributive property. So if I'm trying to distribute, I have to remember what I have to do. Okay, so what I can do is I can just say negative 3 parentheses x plus 2, because that whole thing needs to be multiplied. Same with the other one, negative 6 times 2x minus 1. So I'm going to multiply those. I'm going to bring the arrows to say that means multiplication. Same here too. So that what I can ultimately do is say, hey, I'm going to do negative 3 times x, that's negative 3x minus 6. And then I have the next one. I have now negative 6 times 2, that's negative 12. 6 times 2 is 12, there's a negative sign. And then negative 6 times negative 1, that's positive 6. A negative times a negative is a positive. Right as I have that, remember that we have to make them equal. I'm actually going to write this in red to say that, hey, we have to ultimately make them equal. So I'm going to have this negative 3 minus 6 equals negative 12x plus 6. And guess what? It's just like the same idea, having x's on both sides. I'm going to add 12x to both sides to get rid of one of the x's. The 12x's cancel out, leaving me with 9x minus 6 equals to 6. Going back to two-step. I get rid of the negative 6 right here. It's subtraction. I do addition to both sides. This leaves me with 9x equals to 12. What that does is that I divide both sides by 9, getting rid of it because of multiplication, leaving me with 12 over 9, which is equivalent to 4 over 3, or 1 1/3, or if you really want as a decimal, 1.3 repeated. Let's look at the last one, which I think is considered the most difficult one in the distribution as well as everything else. So I notice that I have distribution right here. But I also notice I have a fraction right here. So you might be thinking, okay, which one do I get rid of? Should I do distribution first, or should I do the fraction first? I think, honestly, you can go either or. I think it helps first if you do distribution first. And then I would focus on the fraction second. If you have multiplication already with the distribution, do it first. So what I'm going to do is I'm going to do the distribution like this, and then rewrite it. I didn't do anything with the 1/2 x, so I'll leave it. Negative 4 times x, that's negative 4. And then negative 4 times negative 2, that's positive 8. I see here I have that that equals to x plus 8. And then what I'm going to do is that I'm just going to essentially make it so that I can get rid of the fraction. How do I do that? I multiply again to every single term. What that gives me, the 2's cancel out, leaving me with 1x. Negative 4 times 2, that gives me negative 8x. 8 times 2, that's 16. 2 times x, that's 2x, plus 16. And then what I can do is I can combine like terms. I see here I have multiple x's on this side, the left side, so I'm going to combine them. Negative 1x minus 8x is negative 7x plus 16 equals to 2x plus 16. Now I have x's on both sides. Let's just say I wanted to get rid of this negative 7x, so I would add both sides by 7x, leaving me this with the 7x's canceling out, equaling to 16x. 16 equals to 9x, 2 plus 7 plus 16. I want to get rid of the 16. I'm getting rid of this one because it's with the x. So I'm going to subtract both sides by 16, leaving me with 16 minus 16. Wait a minute, that's 0. That equals to 9x. Okay, but I have to get rid of the 9, so I divide both sides by 9. What does that do? Well, if I divide both sides by 9, that gives me 0 divided by 9, which, hey, guess what? This whole answer was 0. I know I kind of went fast across all the different problems, but it's essentially just countering these different ideas that kind of mix together, such as how do we multiply with different denominators? How do we encounter both getting rid of fractions and combining like terms? And it gets more difficult, right? How do I combine like terms, or how do I combine fractions with x's on both sides, leading us to doing something with distributive property, and then ultimately with something like this for the distributive property along with fractions. I wish you the best of luck.